AWS. So I'm going to share my desktop along with you. So you can able to see my screen. I think you are able to access my screen. So as said, time consumption is about, so we are going to cover the important labs of AWS, and I think no technical issues from, because I think all are getting my voice properly. So yeah, first of all, we are going to understand about the EC2 Instance and Amazon S3 storages. So this was some what we have, the paid labs for you people, and these all the things that we are going to cover one by one, and we are going to make you more understandable of AWS services, because we know AWS is one of the topmost services in cloud, and we are going to cover these services, and these all the paid labs specifically for you to gain access of the real-time availability of the services, and also you can able to understand the real-time scenarios about these services, and these services is how much effective these services, and how much the services that you are able to gain up, you can able to understand in this lab scenario. So this is absolutely what is it's a great contribution of the services that we are going to present from Zeedup Technologies across you, and that you can able to understand. So you maybe have already some knowledge about these services, or maybe you have some people also have little bit knowledge, or some people also have a good knowledge, or some people have 0% of knowledge all these services. So but today I'm going to clear all those doubts coming inside your mind. So first of all, we will be covering the Amazon S3 storages in our labs. So most probably you may ask questions in between. If you have any questions, you may ask related to that concept. Also, you can ask me any sort of questions related to that topic, and you can able to clear your doubts instantly. So first of all, I'm going for Amazon Web Services S3 storage. So let me switch on the lab. Yes, guys. So I think now you're able to hear my voice properly. There is no echo problem right now, I think so. So everyone is comfortable with my voice? Yes. So let me start working with this all the paid labs that what we have right now. You're able to see in your screen. So first of all, let me cover about EC2 instances, and then we are going to cover about S3 storages, and then we're going to cover about elastic block storages and all. So first of all, when we see about EC2 instances as a real-time access, we know that EC2 is a primary web services that provides resizable compute capacity in the cloud. Fine. So we know that because you maybe already have worked some EC2 instances. So because here EC2 instances where we are going to work a lot of stuffs here as elastic block storages. I can take snapshots and also I can do auto scaling and here and I can able to have a lot of AMI. You can create AMI images and also I can able to work with elastic load balancer. So all those kinds of stuff inside we are working in EC2 instances. So because EC2 instances, this is one that we have different types of virtual CPUs, memory, storage, and network performances. And this because we have different types of instance types. So when I start instances, so these instances, this is something I can say. This is a you can choose which platform you need to access it from here because on how much the manipulation power that you need to access these instances you can able to determine in this EC2 instance, right? So suppose I am just launching a Windows instance, for example, and this Windows instance, the second one showing me choosing an instance type. This is the right type of instance that is suitable for your environment is concerned. And because here the instance type families, we have different types of families, and here we have different instance types like compute optimized, memory optimized, storage optimized, and GPU based instances. So which instances you like, you can select it from that. So here I'm just, this is what is a basic instance called T2.micro, and this contains 1 GB of memory and 30 GB of storage and 2.5 GHz of processor. But if you want, based on your organization needs, if you want more high-level instances, you can able to select from this list, and you can use it for your what type of instances. Instances are different types. Okay, so instances given that based on it's a micro instance, general purpose instance, or maybe because suppose you're looking for more memory types of instances, you can go for studies as your memory optimized because for memory intensive workloads. And then when it comes to storage optimized, this is something called for workloads required high amount of fast SSD storages. And when it comes to GPU based compute, this intent for graphics and general purpose GPU workload. So like this all the instance. So I'm just selecting here T2.micro, and this is the instance details what we have here because this instance details is the accurately I can say that because this is how the instance is stand out about because here you can see we have a default VPC connected here and we're using this default VPC. And basically, you know, when I'm talking about EC2 instances, we have two types of consoles like EC2 Classic and EC2 VPC in AWS. So now EC2 Classic has been wiped out. So we have EC2 instances, okay, EC2 VPC. So Amazon Web Services has been change the consoles into high level, so something called EC2 VPC. Previously it was something different types of consoles called EC2 Classic. So now we are in EC2 VPC, so no need to worry about those EC2 Classic. So my all the instances will be connected to my default VPC, and this default VPC contains of route tables, and this default VPC connected with internet gateways, and also they have subnets or DHCP option sets, and also they are coming under specific availability zone. So this is, I'm free to select any availability zone from this list, and where my specific instance is going to be placed. So I can select my default availability zone, and this is auto S1 IP. This is a public IP, and you should understand that these settings. If I want to have the public IP, I can select it here, or I can able to set. So my VPC will be given two set of IP for each instance. One is public DNS IP, and second one is private IP. So this is if I have Active Directory, so I can join domain. This since I am not configured any identity and access management role, and that's why I'm giving. And this is a stop behavior, and this is the behavior of instance, what they have to do when I'm just stopping the instances right from here in this one. So then we have protect against accidental termination. This is something that you can able to protect your instance from accidental deletion from the user point of view. So you can give this protect against accidental termination, and this is monitoring. So each instance comes under monitoring. So you can enable connect your instance with CloudWatch, and you can have detailed monitoring details about the EC2 instances. And tenancy, this is shared and dedicated one. So shared means it will be less charge for you. If you go for dedicated, it can be more charge for you. Okay, so let me add storage, next one. So by default, each instances supports 30 GB of storage by default, and actually if we talk about storage in Amazon Web Services, we have two types of storage: internal storage and external storage. So I'm just talking about internal storage now. Internal storage have 5 types of internal storages. What we have here, you can see we have general purpose SSD storage, magnetic storage, and provisioning IOPS SSD storages. And also we have cold hard disk storages, and throughput SSD storage is also available in AWS. So that new two types of storage introduced, and one of the most important things is IOPS. This IO input output per second, and more IOPS means more disk capability can be increased as far as the disk rating is concerned. So, but this general purpose SSD does not have IOPS, but I cannot select myself, and magnetic does not have any IOPS for magnetic storage. So I go for provision SSD and tags. And tags is nothing but, as you know, if you have more virtual instances, in order to identify virtual instances more easily, you need to have a tag, and tag is a key value name pair. So right now I'm not going to give anyone, and there's security groups, and these security groups is nothing but that is inbound, outbound security concept, because this is also known as virtual firewall protection, because AWS allows you to control traffic in or out of your instance through virtual firewalls called security groups. And security groups allow you to control traffic based on the port, protocol, and source and destination. And this is depending on whether you are associated with Amazon VPC or Amazon EC2 Classic. So this is different capabilities of things that security groups. So security groups are associated with instances when they launch, and every instance must have at least one security groups, but we can have more security groups also. So okay, so like I'm just click and review on this, and this is the review instance launch. I'm going to launch, and asking me the key pair, and the key pair should be I can select a choose existing key pair or new key pair or proceed without key pair. Can have a new key pair. So let me give AWS demo, and I'm just downloading the key pair from that, and I can having the key pair here. I can save it and launch instance. So this is a basic way of launching EC2 instances inside the AWS, inside the specific region, inside the region, and inside the specific availability zones. So this is I launched, for example. So I'm going to do Windows. So so once I launch these instances from here, so I will be getting two set of IP addresses. One IP is a public IP all over from the AWS, and one can be connected with my private IP, and this is the private IP range. And but since private IP does not connect with my internet gateway, so this private IP cannot able to communicate with my internet connection. So obviously, if I want my private IP wants to communicate with my internet connection, obviously AWS has to provide me a public DNS IP that is called endpoint, and via that endpoint I will be communicating with my internet. So there is a NAT happens between these two, network address translator. So that something done automatically by AWS. Since we are connected with default VPC, so this EC2 instance connected with my default VPC, and the default VPC will provide the availability zone, and they provide the public IP, they provide the private IP, and they provide the rest of the connectivity things for this instance to run inside the AWS cloud. So that's why. So because so I can launch many instances. I can launch Windows instances. I can launch for Linux instances, and I can see how many key pairs are available for me. So I have key pairs. So I have two key pairs, AWS demo and Quick Labs. So if I lost this, AWS does not provide additional key pair if you lost the key pair for these instances. If you lost this key pairs, you need to replace the disk and you need to attach a new disk. Then it will be, I can replace the new key pairs. So here you can see this AWS has provided me a separate DNS server IP addresses, and he's provided me this private IP addresses inside my EC2 instance. So I can launch the instances right now. So I can connect these instances and I can get password from that. So this password will be available at least the gap between I launched this instance between 4 minutes. Actually, this VM instance, because it's still initializing, so we have to wait for that initialization process has to be completed, and then after that, that instance can be launched inside AWS cloud. And no need to worry about the instances passwords, because instance password you can change instantly when you log on to AWS Windows instance. So you can able to change that. I will be showing how to change the password inside that one. See, actually that's why, see, this instance is one of the AWS, one of the most powerful console. I can say this is EC2 instances, because when you launch an instance, okay, there are 3 types of process, that main process that we should understand. The first process is DNS name. This is domain naming system, because when you launch an instance, okay, so AWS creates a DNS name that can use to access the instance, and this DNS name is generated automatically and cannot be specified by user, and the name can be found, you can see here in this description tab here, and the AWS management console, and this is, and we have a public IP, right? This public IP, or I can say a launch instance may also have a public IP address assigned, and this IP is assigned from the address reserved by AWS, cannot be specified. That's why this IP address is unique on the internet, that persists only while the instance is running and cannot be transferred to another instance. And we have elastic IP, so that elastic IP is one more IP, I can say that, because elastic IP is an address unique to on the internet that you reserve independently and associate with Amazon EC2 instances. So while similar, this is as I can say this elastic IP is similar to public IP. Now there are some key differences, because this IP address persists until the user releases it. So if you want to release it, you can release it, this IP, and I can say it is not tied it's not tied to a lifetime or state of the individual instance, because it can be transferred to a replacement instance in the event of instance failure. So it is a public address that can be shared externally without coupling clients to a particular instance. There's something called elastic IP. Okay, so that's why. So when I'm connecting this one, so I try to get password. So it's taking time for me. So let me launch another instance, Linux instance here. See, this AWS is based on Linux, so because because this AWS is to have a complete CLI advantages of accessing instances via AWS CLI instances. So you can easy to stick everyone when they have the background knowledge of the Linux. So that's why as I told, every instance stick with this default VPC and the availability zones. And see these are the important things that you should have, the types of instances. We have on-demand instances, we have reserve instances, we have spot instances. So instances are different types because if someone asks you, tell me the instance types, I can say this is a different types of instance purchasing option method what we have inside AWS, because we have on-demand instance, and we have reserve instance, or I can say spot instance. So the different types of instance types. So right now I am in on-demand instance, so that is per hour. It is going to be charged for me. But spot instance means I can able to bid my price myself inside AWS. After bidding the price, if that price is over for me, if the cost is over for me, the cost link is over for me, then automatically I will be disconnected from the AWS. So that's why. So the pricing option, different pricing options, purchasing option, I can say, first of all, it's on-demand instance. So right now I am in on-demand instance. Every instances has to stick with EC2 or maybe AWS. They have to come via this path in order to launch an instance. So because on-demand means so I am in on-demand instance. On-demand means what? The price per hour for each instance type, and an on-demand instance, one of the most flexible pricing options, because it does not require no upfront commitment. So instance, that's why when come to this is reserve instance. These all things you can able to understand when you come inside the EC2 instance. And when it come to the, as I told, this option, termination protection, that is protect against accidental termination, because when an Amazon EC2 instance no longer needed, the state can be set to terminated, and the instance will be shut down or removed from AWS infrastructure. So in order to prevent termination by AWS Management Console, the termination protection can be enabled for the instance. So while calls to terminate an instance will fail until termination protection is disabled. So this helps to prevent accidental termination through some human errors. Okay. So let me go to add storage. So basically I'm having 40 GB storage, and security groups, and because this is a stateful firewall, I can see security groups, and it have the rules, different set of rules to access the instance, and review and launch it. So I launch it with AWS demo, and I'm just having the same key for this instance to launch. So now two instances I have launched inside EC2 instances. So that's why this EC2 instance is most probably, I can say, this is one of the most powerful console. This is API console where you can able to do a lot of stuff here inside this one. So let me launch this Windows instance, and since get password, so I'm just giving it this password. Go to decrypt the password. So this password is something difficult for you to remember because it is in a cryptographic format. So this AWS EC2 instance, you try to access via RDP protocol, port number 3389. So someone asks you that you can access this RDP protocol via my private operating system, that what we have inside my PC. That's not something possible, because this RDP is specifically designed by AWS to access the AWS connection endpoint for EC2 instances. So this is one of the easiest way to launch Windows instances inside the AWS. And moreover, because you can see this, it's very easy to launch an EC2 instances from Windows inside the cloud, and you can able to add more storages. I can add more EBS storages, and So as I told, we had different pricing list, right? So on-demand instance, and this is it is effective hourly cost, or we may have total 3-year cost of those instances. So now you can see I have launched this one. So this is one basic things that you can launch it. This is the one, and this instance is based in AWS cloud. So same way I can able to launch a Linux instance. A Linux instance has been launched not generally like a Windows instance. I need to go for my PuTTY, so I can connect with PuTTY, or I can use Java SSH in order to have to launch this instance. Okay, so just use to connect with PuTTY, and you can have instance, and then connect instances. I need to change the CH mode. This is the permission that you can give inside, and this you can give full right permissions for that PEM file to access the specific instance. So that is something. This is the method at RS, because this connects on port number 22, and this connects on the port number 3389 instance. So this is 2 instances are running right now. So this Windows instance is switched on. Since I am running as a lower type of instance inside the AWS, so you know what instance I have. I have a 1 GB of RAM, and the name of the instance is Zeedup.micro. So I have a 30 GB of EBS storage inside this Windows, and it seems like same as what we have in private. If you have a private CPU in our home or maybe office PC, it looks like this is an installed operating system inside this drive. And obviously this is a low-level storage. Okay, so when talking about, I will be coming back to about talking about the EBS storages later in our session. So like this, you can able to launch it any number of instances inside the EC2 instances API console, and you can access it the platform that you are looking for in the AWS. Okay, so while we have to understand, suppose you want to extend the size of this instance. That's something that you want to extend the size of this instances. You can do this that simply by extending the size. We know the maximum size for these instances will be up to 16 terabytes. Okay, so this storage, I can say this storage is called a traditional storage, or this is a file storage what we have in AWS. Suppose I need more storage to add inside the instances, so I can go for my volumes. Here you can see here the elastic block store volumes, and just go to click on the volumes, and see I want to extend that instance. So already I have a few things here, and let me go to my this filter by tags. Okay, so no need to worry, just go to instances. So 2 instances already running for me, and just click on this instance ID. So suppose I just copy this instance ID, go to volumes, just paste it. So this is 30 GB, so let me modify this volume. This is, as I told, we have 4 types of storages in this AWS. Okay, so you can able to see here. You can see that there are 2 types of storage showing: general purpose SSD and provisioning IOPS SSD. When come to general purpose, it's go to 1 GB to 16 terabytes. When come to provisioning IOPS SSD, it's come to 4 GB to 16 terabytes. So this is one of the best storage for IO, that is provisioning IOPS storages, because it gives lot of flexibility inside. Because when come to this, this all comes under EBS, that is elastic block storage. We know while instance stores are an economical way to fulfill appropriate workloads, and their limited persistence makes ill-suited for many other workloads. So this is based on the workloads, how much workloads you need to have to an instance. Because Amazon EBS, this provides persistence block level storage volumes for use with Amazon EC2 instance, and each EBS volumes is automatically replicated within its availability zones. So that protect you from any component failure and offering high availability and durability. And this EBS volumes are available in different types of varieties, because they are different in performance characteristics and price. Because Amazon EBS volumes can be attached to single Amazon EC2 instance, and volumes can only be attached to single instance in a time. So here in this example, we have two types of storages, right? We have general purpose SSD storage, and we have provisioning IOPS storage. We have other, because this general purpose SSD storage, this is one of the storage that offers cost-effective storage that is ideal for broad range of workloads. They deliver strong performance at a moderate price point. This is suitable for a wide range of workloads. So a general purpose SSD volume can be, this is a range from 1 GB to 16 terabytes, and provides a baseline performance, 3 IOPS. That's something called, you can see 100/3000, and the capping of, it have capping of 10,000 IOPS. For instances, if you cover 1 terabyte of volume, okay, here, so I think you can expect the baseline performance of 3000 IOPS, and 5 terabyte volumes. If you give 5 terabytes means, but I don't think so. It will not provide any 15,000 IOPS baseline, but it will hit a cap of 10,000 IOPS. That's why this general purpose SSD storage is all about. And you need to understand the more about these storages. So because we are focusing only on the practical session. So if I'm not going to focus so much of inside their concept, because we have a lot of concepts stick with inside these storages. And this is important for you to understand these storages, because this storage is something comes under the traditional storage or block level storages, and these types of storages is not called external storage, but these types of storage have some limitations, right? So let me increase my storage here. Suppose I'm going to give 1 terabytes. Okay, so I'm going to give let me increase some click modify, click yes. Okay, so requesting volume modification, I got successful, and go to refresh. You can able to see the changes inside things. Yes, I got it. Now go to EC2 instance here. Okay, now the storages is not added here. Go to this management of MSC. So it will be reflected immediately inside this one. You can see, go to refresh. You can see here. This is split into 2 times, 2018 GB and this 7952 GB, and this is something unallocated. So I will be allocating for you right now inside this one, and it will be very interesting also when you work on this one. So suppose I am running out of the disk here, I can able to extend the volume here, and this is general concept of disk management what we have. So click on this one, it will be extended here. So in this case you want to create a separate partition, so you can go to CMD and you can able to so one question asked, so only when you modify the store for free tier, is a free tier will charge for your timely use? Actually, when you modify the store for a free tier, actually the free tier means 750 hours will be free, not more than that. But AWS will charge for me timely use, so up to 750 hours whatever the things is free, that is not chargeable. Above 750 hours whatever the things is not free, it won't be chargeable. When come to, okay, so next question is storage. That question I not understand it completely. So you can use some disk capabilities things here in order to store, in order to create more partitions here. Suppose okay, go for Any limit on storage space volumes? Yes, there is a limitation. As I told already, 16 terabytes is a maximum limitation for EBS storages. So there are four types of EBS storages, as I told already. Totally, we have magnetic storages, we have IOPS provision storages, we have general purpose SSD storages. These three storages AWS has already introduced in their storages inside EBS. So, and after that, recently in 2017, AWS has released other two storages added to that. One is through throughput HDD storages and cold HDD storages. But those two storages also have the 16 terabytes of limitations. So this is not some S3. This is not like S3 storages that you can store data unlimitedly inside a bucket. This is a storage that we have in our private data center. You know, in private data center that there is a storage limitation, right? They will not give any storages, and they don't have any unlimited number of storage. They have a limitation of storage. Same one is here. This storages is stick with operating system. This storage is stick with databases. This storage can stick with other AWS services that related to EC2 instances. But these storages will not be these storages holding the operating system, just like we are installing operating system on specific drive. The same one this storage is all about. But come to S3 storage, S3 storage is not holding any database. Inside S3 storage, you cannot install operating system. Inside S3 storages, you cannot able to find any of the operating system activities, or you cannot find any of the database activities inside that. That S3 storages is an unlimited number of storage, and that S3 storages does not have any file system. And S3 storages does not comes under any limitation of the file system, or maybe any basic disk or dynamic disk. So this EBS storage is 100% completely is a block level storage, and these storages will be attached inside the operating system all the time. So whenever accessing this one. So any limitation on storage and volume space? Yes, we have limitation. So 16 terabytes is the maximum storage size we can create it in this EBS. When come to this one, you can use this one with some commands to have a partition, to create a partition. So I can give this list disk. You can able to see I have this number 0, and this number 0 is this disk, and this is the one which is I'm talking about, this 0. And I'm going to create some partitions here in this EC2 instances of Windows. So let me create it here. Those partitions are okay. So there's no case should mean there's no be selected in this partition. So first I need to select it. So you can see this is so now I'm going to suppose I want to have extended partition. So I have to extended. So inside extended I'm going to create logical. I'm going to, this is 7,952 GB of storage. I can give 5,000. Now you can see this is telling that I'm not having sufficient free space to create this one. So let me give, okay. Okay, so this is telling that is I am exceeded because no usable free extent could be found if there is insufficient free space in create. Okay, so this is the size. So when I go to try to have it, because this is not created, because this is basic disk. So I can able to okay, so I cannot able to add this one because it is already, I think the usable space will be high, because this I'm using MBR, okay, MBR master boot record. So master boot record will have only 1 terabyte, again 2 terabyte of storages, not more than that. So that's why this the one. Yes. So let me string some volumes here. So let me string some volumes here, and then I can use it for this. So these all things what we are working, this is a traditional level of storage is what we have in AWS, and these types of things we are working as a elastic block storages. And when come to this different use cases point of view about the EBS storage, what we have. So someone asks you, that tell me what is the difference between SSD storage and provisioned IOPS storage and magnetic storage. This is some people will think that this is one of the most difficult question to answer. This is not something like a difficult question to answer. It is easy to answer because you have to understand that if the storages right now you're able to see this drive. This is a raw drive. About this you can see KB. So this is a raw drive, and I can say this if this is a general purpose SSD storages, you can use it for system boot volumes, for virtual desktop, small to medium size databases, and you can use for that test environments. And the volume size, what you ask, I can say if this is a general purpose SSD storage, the volume will be 1 GB to 16 terabyte, and maximum throughput is 160 Mbps. When this is a provisioned storage, means provisioned storage is designed for critical business applications that require sustained IOPS performance, or more than 10,000 IOPS or 160 MB per volumes. So in this manner it is created. So that's why when I create a volume, these types of storages came into existence here. Oh yeah, this is you can see this is the total number of storages that came into this existence. I think you can see here general purpose IOP. As I told, this provisional IOPS is one of the most wonderful storage compared to other one. And as I told, provisional IOPS storage is required. Is a critical business application storage that require IOPS more than 10,000, and this is used for large databases and databases workloads. And this capacity will be 4 GB to 16 terabyte. And when come to this magnetic disk, actually this is the storage that is used for cold workloads where data is infrequently accessed. Scenario where the lowest cost storage is important, and the volume size will be 1 GB to 1 terabyte. You can see 1 GB to 1 terabyte, and like this, because this is how this storages has been drifted in AWS EBS. When come to this two new type of storages AWS introduced, as I told, throughput, optimized HDD and cold HDD, because it is expected that these new types will be eclipse the current magnetic volume type, fulfilling the needs of any workload requiring hard disk performance. When come to this throughput optimized HDD, this is a low-cost HDD volumes designed for frequently accessed and throughput incentive workloads as a big data warehouses and log processing. Because the volume size for this throughput is I can go. This also goes 16 terabytes with the maximum IOPS of 500 and maximum throughput speed of 500 Mbps. And these volumes are significantly less expensive than general purpose SSD. When come to this whole as you can see the size 500, as I told, 500 then GB to 16 terabytes. When come to old HDD, these volumes are designed for less frequently accessed workloads in EBS, such as colder data requiring few scans per day. And volumes, this also volumes go 16 terabytes with maximum IOPS of 250 and maximum throughput of 250 Mbps per second. And these volumes are significantly less expensive than throughput optimized HDD. You can see here, this is also 500 GB, 16 terabyte. So these volumes, this is all EBS volumes, different types of volumes like what we have. So we need to have a good knowledge of this storages, because this is important when come to different EBS volume types comparison point of view. and you should be in the great position in order to understand, in order to answer all those types of storages what we have. And you know that the AWS, because they provide encrypt this volume option, okay, this encryption, because many workloads have requirement the data to be encrypted at rest, either because of that is compliance regulations for internal corporate standard, because Amazon EBS offers native encryption on all volumes. And many people are wondering that what type of encryption that AWS EBS provides for us. I can say that because AWS EBS, that's why when I select this option, encrypt this volume, AWS uses KMS, called Key Management Services, to handle key management. That there will be a master key will be created for us, and the data will be associated with those encrypted keys with industry standard protocol AES 256-bit key algorithms, and the encryption occurs on the servers that host Amazon EC2 instances. So data is actually encrypted between the host and storage media. So the encryption is transparent to us. Okay. So if you ask me where is the AWS KMS, I cannot answer this because encryption is transparent to us. So all the data access is the same as an unencrypted volume, and we can expect the same IO case performance on encrypted volumes as you would with unencrypted volumes. So with minimal effect on latency. And so that's why when you used to take snapshots that are taken from encrypted volumes or automatically encrypted as our volumes that created from encrypted snapshots. And that's why this storage is all about in this instance. So that's why. So this instances is the one. And see, as I told, we have a lot of instances stuff is going on. We have a spot instance and we have reserve instances and all. So like this is a EBS storage, and this EBS storage always stick with Amazon EC2 instances. I hope you understand that. Let's move to next level. So let me talk about next is VPC, that is Virtual Private Cloud. You people may be wondering about this VPC. What is VPC is all about, because Amazon Virtual Private Cloud, you know what is Virtual Private Cloud. Since Amazon is a public cloud, so you can able to communicate AWS as a private cloud. So this means you can able to communicate with AWS if you're running a private offices between two locations, you can have a private cloud that is called VPC connection between those two different sides of the things. But it is interesting fact to understand about the VPC, because VPC is the one I can say Amazon VPC, they provide two types of services for us. One is public and one is private. So the name itself says Virtual Private Cloud. Okay. So Virtual Private Cloud is a custom defined virtual network within AWS. So I go for the VPC. And as I already told about that, we have a default VPC inside AWS. And that default VPC is something created upon the EC2 instance started. So that's why this VPC is because many people are getting struck with these concepts of VPC. But VPC is the one which is this is I can say this console. This is API, and this is a custom defined virtual network within AWS cloud. So you can provisioning your own logically isolated networks of inside AWS, similar to just designing and implementing a separate independent network that would operate in on-premises data center. So that's why it's Amazon VPC, because you should have a strong understanding about VPC, because VPC is a network layer for Amazon EC2, that is called Elastic Compute Cloud, and it allows you to build your own virtual network within AWS. So you control various aspects of your Amazon VPC, including selecting own IP address range, creating your own subnets, configuring your own route tables, network gateway, security settings, within a region. So user can create multiple Amazon VPC, and each Amazon VPC is logically isolated, even it is shared its IP address spaces. So that's why this VPC. So see, as I told, we have two types of VPC. One is self-created VPC. There is default VPC. One is self-created VPC. In order to understand this VPC concepts, you need to be strong in IP addressing structure and their general formats, because if you have to understand about CIDR, classless inter-domain routing, because CIDR is a block and it tells us how much free available address or are available for us to continue with the same subnet. Because this we have actually AWS has done to has been drifted into two types of consoles, right? As I already told you, EC2 Classic and EC2 VPC. Nowadays we are not stick with EC2 Classic consoles, because many people stick with EC2 Classic consoles still in AWS. So we are not stick with EC2 Classic, we stick with Amazon EC2 VPC, because Amazon EC2 VPC is the because Amazon EC2 originally launched as a single flat network shared on AWS, and AWS accounts created in this VPC. Okay, so this is VPC. Okay, I can go first. I can create my own VPC here. Okay, because here a lot of things you need to understand that. So you need to understand like what do you mean by these subnets and route tables, internet gateways, this option, DSCP option set, elastic IP endpoints, peering, and security and VPN connection. See, actually, if I start creating my own VPC here, I can able to stick this. I can able to stick my EC2 instances with this specific network subnet, and I can ask for AWS and give me one elastic IP, elastic public IP to access my EC2 instances. That is separately created VPC EC2 instances can able to access internet connection. So actually Amazon Web Services gives us freedom for us to have a virtual private connection connected subnets between two different sites. That's why we need to, first of all, we stick with subnets. So what is subnet? Subnets is a segment where we are just launching a, what is a separate subnet of instances. So that's right. So we have different types of. So I can create many subnets in this Amazon VPC. So subnet, actually, if you're coming in networking background, that you can understand what is subnets, because subnet is the segmentation of the network, and I can say subnet is the one which is closely associated with our networks around. So suppose I'm giving this VPC name. Suppose I'm giving AWS. Okay, so this is the how. Then this is asking me to give my CADR. So this is, and I can give any number of any IP that's maybe, but I should give the private IP, and you can able to see that if I give this CADR, well, it has 65,531 IP addresses are available for me. When come to this this subnet /24, I can able to see 251 IP addresses available. How these calculations are going on, are able to understand here, because how these calculations are going on. This calculation is going on by submitting, the process called submitting. You should calculate, take your pen and paper and sit and check your CIDR table. That CIDR table is listed in any sort of the Google's the Google search engine. You can type CIDR, and they have huge list of a table that shows you that they'll show the real calculation of subnets. So because why we are using the CIDR, classless inter-domain routing method, because in order to get more free IP addresses, in order to give more free segments, because IP address wastages you should not do in cloud, because many people will do wastages of IP addresses, but here we should not waste any IP addresses inside the cloud. And someone asked one question. Suppose I have two CADR blocks. Okay, one CADR blocks is something called 10.0.1.0, and another CADR blocks is 192.168.0.0. I think you're keeping this IP address right now in your mind, because I don't want you to lose those IP addresses examples that I'm explaining right now. So just remember, we have two types of CADR blocks, 10.0.1.0 and 192.168.0.0 with respective /24. you know, one of the smallest subnet that you can create is /28 bit. Okay, so when I get /28 bit, okay, you can see here this must be a CADA block. Okay, because it has 16 available IP addresses. Okay, so let's say suppose I'm giving 24. Yeah, so it's showing this is must be a where it must be very CADA block. So it is the very CADA block. So when I go back and come again, and this Amazon itself gives me this IP addresses and all. So that's why, as I told, see every subnet, okay, every subnetted that you create in AWS. You know, AWS reserves first 4 bytes of IP addresses and last IP address for every subnet for internal networking purposes. This means a subnet defined, suppose I'm giving a /28, and if I give /28 means I have 16 available IP addresses, that they have to subtract 5 IP addresses from that, because AWS will take first 4 IP addresses and last 1 IP addresses as a reserve. So 11 IP addresses that is available for use for within a subnet. This is how the AWS will take. And someone asked you, tell me the default VPC connection concepts. Default VPC, see, actually, as I told, after creating Amazon VPC, you can add one or more subnets in each availability zone. And you know, subnet resides within one availability zone, cannot span zones. So that's why this is an important point that you should understand. So you have to remember that one subnet equals one availability zone, but multiple subnets, you may have multiple subnets in one availability zone. So one availability zone can contain multiple subnets. So we have 3 types of subnets we have available here. One is public subnet, one is private subnet, one is VPN only. And now by default this is a public subnet. So I can define what type of subnets that is. As I told, if you ask me what is public subnet and private subnet and VPN only, I can say that public subnet is the one in which actually every subnet is associated with one table called root table in AWS VPC. That root table used to direct the subnet traffic to Amazon VPC, that is called IGW, that is called Internet Gateway. Just remember, in VPC every subnet is associated with route table, and via route table that subnet will communicate with my AWS IGW, that is called Internet Gateway. And via that Internet Gateway we are able to getting the that is a public IP, and we are getting the NAT translations, and we are getting the internet connection from that. That's why public subnet is the one that is it directs the subnet traffic to Amazon VPC IGW. When come to private subnet, is the one I can say in which the associated route table does not direct the subnet traffic to Amazon VPC IGW. So VPC only subnet is the one. I can say that VPN only subnet is the one in which the associated route table directs the subnet traffic to Amazon VPC. This and does not have a route to IGW. Like these are different types of subnets, and you know we have an internal IP. Internal IP means this is a private IP, and that private IP is always non-routable on the internet. Okay, so let we have create VPC. This is creating. I can so now see route table is created, then subnet is created, then internet gateway, then attaching gateway, then enable DNS, and finalizing those things. So I have successfully created one VPC, and this VPC is attached here. So that's why see actually I can select this one. I can see I can have different types of things here. So first of all, because VPC is a concept that you should understand in depth. VPC is a concept that you have to, because VPC is not we cannot take as a lightweight component as some lightweight components as we have in AWS, because it sticks with lot of things. Okay, so this is a subnet. Okay, this is subnet, and one of the AWS's default subnet is this 172.31.0.0. In case of I'm just launching an instance inside EC2. Okay, inside EC2 I'm launching an instance. My private instances, my private IP always will start with this 172.31.0.0, and that's why AWS will do that. So okay, let me launch an instance here. Suppose I'm just launching an instance by default. Okay, so Now you can check here. So here itself, I came to VPC management. See, so here I can stick with my, you can see two VPC camps, right? So one VPC already I have as a default VPC, one VPC I have created right now. So you can see here, 251 available IP addresses available for me, and I can able to enable this auto-assign public IP, and I can launch an instance. So launching an instance inside the specific VPC. Okay, so the VPCs are two types. One is a self-created VPC, and next one is a default VPC. So default VPC, by the way, don't delete this default VPC, otherwise it will create a security issue for you. Once you delete the default VPC, then you have to contact with AWS customer care in order to restore the VPC for you. So this default VPC is the one which is every EC2 instance stick with by default. So when when I have created self-created VPC, so I can stick my EC2 instance with the self-created VPC, and I can able to ask for more public IP address from that. That's why when I come back to this console, let me go back to my VPC console here. Actually, we have to understand, as I told, I think you understand about the subnets. Next, we have to understand about the route tables, okay? Because every VPC have route tables. Okay, now what is mean by route tables? When I go to this route tables, route table is a logical construct, okay? Within, I can say, within the Amazon VPC that contains a set of routes called routes, okay? I can create a route table here. And you can see I'm creating route table for my own created VPC, and I'm going to give some AWS like this is created. So it's creating for me a route table. Yes, it's created, and you can see I can make this route table as a set a main table. When I'm setting this subnet as a main table, then my default VPC will be removed from my AWS. So all the EC2 instances now I'm launching, they will be communicating with my this route table via, and so anytime I can delete this one, I can set as a main table. That's why I told route table is a logical construct with Amazon VPC that contains a set of roles called routes that is applied to the subnet and used to determine where network traffic is directed. And route table routes are what permit Amazon EC2 instances with different subnets within Amazon VPC to communicate with each other. So that's why. So this is how these route tables. And then you need to go to understand about the internet gateways, because internet gateway is the one that is important for us to, because he gives the direct access. Okay, he gives the direct access, and this is IGW. I can able to see. It is de-attached, right? Now it de-attached. So I need to attach to VPC. That's why I said internet gateway is horizontally scaled. See, actually now I am discussing with you everything as a every topic like subnets, route tables, internet gateway, only 20%. Okay, I am not discussing those topics 100%. If because of time consumption is there. If suppose if you come to learn about the VPC or any of this AWS certification like solution architecture or sysops or any solution professor certification, we are going to teach you in depth. Okay, so now I'm just talking about a little bit of those concepts, because those concepts take a lot of time for us in order to complete our task. So that's why I'm not taking so much of the timing. So inside this one, so that's why. So, but in between you can able to ask me any types of questions that you are getting inside your mind. So you are welcome. You are most welcome if you ask any questions right now in the sessions. I think is anyone have one? Someone have one question? So because he turned on his mic on. Okay. Mr. Mahesh. Yes, Mr. Mahesh, you have any questions? Because you are audio is turned on, so I'm getting a disturbance from that. If you have questions, you can ask me, Mahesh. Otherwise, you just mute your audio, please. Yes, I'm getting a lot of disturbance, Mahesh. If you have any questions, you can ask me. Otherwise, you can mute your audio, no problem. Yeah, Mahesh, are you able to listen me? Okay, thanks. No, still not muted. Okay, I think you are busy. Okay, no problem. Let me continue. So that's why I'm talking about internet gateway. See, actually, what is internet gateway? In my talk or talk, because as far as this internet gateway is concerned, it's a horizontally scaled, redundant, and highly available Amazon VPC component that allows communication between instances in your Amazon VPC and internet. Because this IGW that provides a target in your Amazon VPC route tables for internet routable traffic, and it's perform network address translation for instances that have been assigned public IP addresses. Just remember, the public IP addresses has to go past for internet gateway in order to get the NAT translations. That's why, so Amazon EC2 instances, the Amazon EC2 instance, one of the closest services for VPC. That's why Amazon EC2 instance within Amazon VPC are only aware of their private IP addresses. That's why when traffic is sent from the instance to the internet gateway translates the replay addresses to the instance public IP addresses or elastic IP addresses and maintains a one-to-one map of the instance private IP addresses and public IP addresses. That's why when instance receives traffic from the internet gateway translates the destination addresses, public IP addresses to the instance private IP addresses and forward traffic to Amazon VPC. So I'm going to attach that in my internet gateway to the VPC. Yes, it's asking me to attach. Yes, attach it. But it's asking me here, cancel. Okay, so I think let me attach it. Right, now it is attached. So because already one or more VPC, that is self-created VPC attached, so when I deattach, it is attached here, and this is my default VPC. So that's why internet gateway is the one which is do those things. Just remember this, via this internet gateway we are getting the NAT translations and all. Okay, when come to this, because every EC2 instance which is attaching with the VPC has get a set of DHCP option sets. Okay, that DHCP option sets is important for, because you know DHCP, dynamic host configuration protocol, and this dynamic host configuration protocol will do what? It just give automatic IP address to the clients, right? So that's why the DHCP option set in AWS is a standard for passing configuration information to hosts on TCP/IP network. And the DHCP message contains different set of things here that you can say we have domain name, the DNS, NTP servers, NetBIOS name servers, and NetBIOS node types and all. So that's why. So suppose I'm going for EC2 instance, for example, right now here. Suppose I'm watching review here. Okay, so here you can see, okay, I got some problems here in my security groups. I think now it's okay. Okay, launch it. Okay, so I just account for choose system key pair, that key pair deleted. Okay, no problem. So here, when I'm launching the instance, instantly I got the public IP from here, and yes, Mr. Mahesh, please can you able to mute your audio? I think you are able to hear me, Mahesh, because we are getting a lot of disturbance from that. I don't want to because I think you're listening, Mr. Mahesh. Okay, so let me find him here. Okay, so I have muted him. I think no problem. Okay, fine. So let I come back to here. See here I'm just talking about my DHCP, okay, option sets. See, someone asked you, where is my DHCP option set in my VPC? I can able to see here. Yes, that's a good question, because see, AWS automatically creates an associated DHCP option set for set for Amazon VPC upon creation. Okay, so we have two set options, like we have domain naming servers, that is default Amazon provided DNS, and domain name, that is default to domain name for your region. Just remember, we have two types of DNS. Okay, one is AWS Amazon provided DNS, and the second one is that is defaulted to the domain name for that specific region. Okay, so that's two things are there inside this one, and this DHCP option set in VPC, they provide everything they need for EC2 instances. So they provide domain names. As you can see, these types of names. Okay, this IP, the private IP that you are accessing here, and this private IP is something given by DHCP server automatically, and that's why this DHCP option set elements of Amazon VPC allows you to direct communicate with EC2 instances and name assignment for own resources. To assign your own domain name on your instances, create a custom DHCP option set and assign to Amazon VPC. And because here you can see is giving a lot of stuff for us here. So that's why I go to this VPC DHCP option set. Because DHCP option set is the one that give node bias name servers, node bias node type, NTP servers, and this domain name, everything here is offering us. By default, Amazon Web Services default VPC itself creates all those things and given to our EC2 instances. So this DHCP options is as I told, is a standard for passing configuration information to hostess on and TCP IP network, and this option fields of DHCP message contains configuration parameters. That's something important for us, a domain name and those things. So AWS automatically creates it is all automatically created and associate DHCP option for VPC for EC2 instance, and that's why I told, as I had, we have two types of DNS. One is Amazon provided DNS, and second DNS is the DNS name for our regions. I hope you understand this one. So no need to create DHCP option set right now here. Otherwise, if you want, we can create it. Okay, when come to this elastic IP, because many people are getting a wrong intention about this elastic IP is all about. AWS maintains a series of public IP addresses in each region and makes them available for you to associate to resource within your AWS, the Amazon VPC, because an elastic IP is a static public IP. Okay, see, this is a static public IP in this series of I can say pool for a region that you can allocate for your account. So you can pull from the pool or release return to the pool. Elastic IP allows us to maintain a set of IP addresses and they remain fixed while the underlying infrastructure may change over time. So that's why. So I can allocate new one. You can see allocate. I got the new elastic IP from here. You can see this is very easy for me because elastic IP. We must allocate elastic IP for use within VPC and then assign to the instance. When elastic IP are assigned to the region, okay, that's elastic IP one region cannot be assigned to instance within Amazon VPC in the different region. So there is a one-to-one relationship between network interface and EIP, elastic IP. And some people will say you cannot move elastic IP from one instance to another. You cannot. This is absolutely not true because you can move one elastic IP from one instance to another, either in same VPC or different VPC within the same region. And elastic IP remain associated with your AWS account until we explicitly release them. I want, I can release them. Okay. I want, I can release them. You can see, I can release this. Then he just go back to his pool. This is how elastic IP are. And you know there are more charges for elastic IP allocated for your account, even when they are not associated with the resources. And so if you want, we can have it elastic IP addresses inside our VPC. When coming, we have one more called elastic network interface. You know what is meant by elastic network interface? When I go to my EC2 instances here, so today we are discussing everything about AWS Solution Architecture is all about, because I'm not discussing about developers, okay? I'm discussing about the solution architecture, that is compute, storage, databases, and networking. So, you know, AWS gives us SHA model, that is, I can say share responsibility model. Okay, SRM. So share responsibility model, something 50% responsibility taken by us and 50% responsibility taken by AWS. And what are the 50% responsibility taken by AWS? The first, the regions, availability zones, edge locations, and also computes. And actually, regions, availability zones, and edge locations, this all responsibility taken by AWS. But storage, compute, network, and also the applications, the operating systems we are launching in EC2 Instance, that responsibility has to be taken by user. So that is something called share responsibility model between AWS and the user, because AWS is responsible for giving the regions. AWS is responsible for allocating the availability zones, because the first concept, everyone has to stick with regions. Inside the region we have availability zone. If there is no availability zones, then that's all. So there is a fundamental concept that if there is a region, there must be availability zone. If there is no region, there is no availability zone. So region first, then availability zone, then we are come to AWS components, maybe compute, storage, networks, and databases. Okay. Then here I'm talking about that is elastic network interface. Okay, elastic network interface is the one that interfaces are given by AWS. You can see this is elastic network interfaces, and you can see elastic network interface is a virtual network interface that you can attach to an instance in an Amazon VPC. An elastic network interface, I can say it's only available with your Amazon VPC, and they are associated with subnets upon creation. When the subnet is created, same time it will be created. So I can say you can have one public IP address and multiple private IP addresses. So if there are multiple private IP addresses, well, I can say one of them is primary, assigned a second network interface to an instances. This is elastic network interface allows you to have dual homed network. Dual homed means the network presence in different subnets. And ENI means elastic network interface is created independently of a particular instance spaces regardless of the lifetime of any instances to which is attached. If an underlying instance space, the IP address may be preserved for attaching the ENI to replacement instance. That's why this ENI, that elastic network interface, allow you to create management network, use network and security appliances in your Amazon VPC that create dual homed instances with workloads, roles, or distance subnets, or create a low budget and high availability solutions. That's why. So this is Many people say this is not that much important to understand about the elastic network interface, but it's not something like that. It is important for us to understand because elastic network interface, because this network interface is something that we are accessing inside our AWS EC2 instances, and AWS VPC given a full support to elastic network interface, where you're getting all the attachment details. You can see the VPC ID, attachment owner, and attachment time, and also you can see private IP addresses and public IP addresses, elastic IP, and security groups and all. Okay, now we'll come back to this VPC, because Amazon VPC have one more important thing called endpoints. Okay, that endpoints, because you should know about the endpoints. What is endpoints, right? Because AWS, we go to any component inside AWS, they give end of the day, end of the configuration, they give one endpoints. Okay, that what is endpoint? Because Amazon endpoints, I'm talking about this endpoints here, because here inside VPC you can see endpoints. I can create endpoints. First of all, let me explain what is endpoints. See, actually an Amazon VPC endpoint, okay, I'm talking about Amazon VPC endpoint. I'm not talking about Amazon EC2 Instance endpoints or Amazon RDS endpoints or a Redshift endpoints like this. I'm talking about Amazon VPC, because every management component that we have in AWS, they should have an endpoint. And where that endpoint, we are able to access that component outside of AWS or inside of AWS. So Amazon VPC endpoint enables you to create a private connection between your Amazon VPC and other AWS services without requiring access over the internet or through NAT instances, or maybe via VPN connection, or maybe AWS Direct Connect. So you can create multiple endpoints for a single service, and you can use different route tables to enforce I can say different access policies from different subnets to the same service. That's why this endpoints is very useful for us. And you know, Amazon VPC endpoints, okay? Amazon VPC endpoints currently supports a different communication with Amazon S3 storages and other services expected to be added in the future. And you can see here, these endpoints may be complicated for you to understand. Maybe it's complicated for you to because the implementation is something like this. Because here you can see that we have to specify the VPC. I'm selecting a VPC, that I created VPC, and I'm going to select a services, because select a service means a service is identified by a prefix list in the form of the .com, Amazon, and this is the availability zone, and we have to specify a policy, because policy means full access, or create a custom policies. This policy can be changed anytime, because here you can see got the custom. Okay, I can have my own policies. I go to full access. This is a script what we have, and we need to specify a route table. Okay, no problem. I will go for this policy that is called full access, and go to next. You can see when I go next, this is the example that he searched for my route table. Yes, because route table that have existing route that directs all the internet traffic to internet gateway. So any traffic from the subnet that is distinct for another AWS services, for example Amazon S3 or DynamoDB, will be sent to internet gateway in order to reach that services. That is why this endpoint is all about. So because route table, as I already told, route tables will maintain all internet gateways separately. Okay, one route table for routing rule and another route table for VPC endpoint. So the route table, I can say, will direct any traffic from the subnet that is distant for Amazon S3 in same region to the endpoint. On all other internet traffic goes to internet gateway, including traffic that is distant for other services for Amazon S3 in other regions. So no problem. So I'll be selecting this one, okay, and creating endpoints. That's why this endpoint is all about. Just as I told, just remember this endpoints is the one which you create a private connection between your Amazon VPC and another AWS services without requiring access over the internet or through NAT instance or VPN connections or AWS Direct Connect. So that's why this endpoint is important. Then peering. Okay, what is mean by this peering connection? Okay, so this is I can say this concept, this peering connection, is something and maybe new to you, because this peering connection Because suppose you have experience of your private data center network, I can say it is easy for you to understand and think that what's going on in your network. But when come to cloud network, because cloud network is something different from your on-premises data center. Because on-premises data center is easy to establish, easy to maintain, easy to deploy, and easy to troubleshoot, and easy to interoperable. But come to this this cloud network. Cloud network is a world-class network and one of the most wonderful networks what we have in the cloud. We cannot see the cloud network performance in our private data center. That is why AWS now today powering up our private data center with their connectivities. And suppose if you're running a database, your database is not getting that much sufficient of hardware configuration, because day by day the databases need more hardware performance from your bunch of servers. But I'm damn sure that if you're in private office or private data center, your private data center never fulfill the database requirement. That's why, so when you go to connect AWS cloud computing, so AWS powers up more, but your private data center will be getting lot of clusters. They're getting lot of high availability services from AWS, and your databases will start running very smoothly, and your office network will be happy. That's something called hybrid cloud I'm talking about. Okay, so let's come back to peering connection. Actually, see, in order to understand VPC, okay, Amazon VPC peering connection, I can say, is a networking connection between two Amazon VPC that enable instances in other Amazon VPC to communicate with each other as if they are within the same network. So you can create Amazon VPC or peering connection between your own Amazon VPC or with Amazon VPC in another AWS accounts with single region. And peering connection is neither a gateway, it's not an Amazon VPN connection, does not introduce a single point of failure for communication. So when I'm clicking on this peering connection, I can see a lot of stuff is going on here, because peering connections are created through request accept protocol. The owner of the requesting Amazon VPC sends a request to peer to the owner of the peer Amazon VPC. This means there are two accounts associated with him. So if the peer Amazon VPC is within the same account, it is identified by its VPC ID. Okay, we have VPC ID. If the peer VPC is within the different account, it is identified by account ID and VPC ID. So that's why the owner of the peer Amazon VPC has 1 week time to accept or reject the request to peer with the requesting Amazon VPC before the peering request expires. That's why Amazon VPC may have multiple peering connections, and peering is one-to-one relationship between Amazon VPC, meaning two Amazon VPCs cannot having two peering agreements between them. Also, peering connections do not support transistor routing. Many people will say that peering connection will support transistor routing. That is absolutely false, because peering does not support a transistor routing. For example, I have a VPC A, VPC B, and VPC C. Keep design this in your mind. VPC A, VPC B, and VPC C. Then I can able to say that now VPC A has to have two peering connection between VPC B and C. But therefore, VPC A can communicate directly with VPC B and C, because peering connection does not support transistor routing, as I told. VPC A cannot be transistor point for traffic between VPC B and VPC C. So that's why in order for VPC B and C to communicate with each other, the peering connection must be explicitly created between them. This is how, as I told, the peering. That's why it's asking me the tag name and the VPC requester. Okay, I'm selecting this one, associate, and my account or another account. If I click my account, I create a peering connections. So it will be now you can see there are, because I don't have any VPC ID. So that's why. So I had to go for my another account. So it be asking me an account ID and VPC accepted. So to create having the peering connection between me and him. So this is how the peering, as I told, the important things to understand about here. So you cannot create a peering connection between Amazon VPC that have matching or overlapping CADI blocks. And you cannot create a peering connection between Amazon VPC in different regions. And Amazon VPC peering connection does not support transistor routing. And you cannot have more than one peering connection between same two Amazon VPC at the same time. This is how important things about this peering connections is all about. When come to the security groups, actually this in this VPC, when we come, this peering connection is not important that much for we need to must have a peering connection in order to launch EC2 instances. It's not something like this. When come to this security groups is all about. Actually, this is some of the default security groups already created, because I can say the security groups are virtual firewall, stateful firewall that controls inbound and outbound network traffic to AWS resource and Amazon EC2 instances. So all Amazon EC2 instance must be launched into a security groups. Okay, if a security groups is not specified at launch, then instance will be launched into default security groups for Amazon VPC, and the default security groups allow communication between all resources within the security groups and allows all outbound traffic and denies all other traffic. So this may change the rules for default security groups now. That's why these security groups already I can create more security groups here. I go for my this, maybe this. So I created, and I can delete the security groups here. So this security group I can attach with all the EC2 instances. What are things I'm just attaching here. So many people stuck with this security group. Just remember, you can create 500 security groups in Amazon VPC, and you can add 50 inbound and 50 outbound rules for these security groups. If you need apply more than 100 rules means, and you can associate up to 5 security groups within each network interface. And this is how security, but don't confuse with the security groups. And we have one more concept, network ACL, because network ACL is something different, because it gives a lot of more security for it. Just remember, when you understand security groups, you can specify allow rules, but you cannot specify any rules in the security groups, and this is important. Then come to understanding about this network access control lists. Yes, so yes, network access control lists. So this is one of the another layer of security that acts as a stateless firewall. But that's why I told, when you go to this security group, this is a stateful firewall. When come to this one, it's a stateless firewall. So a network ACL is a numbered list of rules that AWS evaluates in correct order, starting with the lowest number row to determine whether traffic is allowed in or out of any subnet associated with the network ACL. Because Amazon VPC, because here Amazon VPC will give, like I say, will give the modifiable default network ACL associated with every subnet that allows or inbound and outbound traffic when you create a custom network ACL. And it is its initial configuration, I can say, will be denied. Okay, will be denied all inbound and outbound traffic until you create rules that allow otherwise. So you may set up a network ACL with rules similar to security groups in order to add a layer of security in your Amazon VPC, or may you choose. But this ACL, I can create ACL. This does not filter traffic that is transferencing from subnet boundary. So every subnet must be associated with the network. So let me give this one as created. So this is created, and I can able to get it. So a few things you have to remember about the network ACL. It's not that much very tough to understand network ACL, because there is a difference between these two, network ACL, security groups. This is a major question we are getting in many interviews. What's the difference between network ACL and security groups? Because you should know the gap between between a network ACL and the security groups, because this is important for us to understand. Okay, so next this VPN connection. Okay, this is the one of the most high level of connections that I can say inside my VPC. Okay, so when I go to customer gateway, or I can go for NAT gateways or NAT instances. So when I talk about this, first of all, before going this, when I go to NAT gateways, most probably you know what is NAT. NAT is a process of just converting public IP to private and private IP to public. So by default, any instance that you launch into private subnet in an Amazon VPC is not able to communicate with the internet through IGW. What do you mean by IGW? Is Internet Gateway. So this is a problematic if the instances within private subnets need direct access to internet from Amazon VPC in order to can say apply patches, download patches, update application software. That's why AWS provides NAT instance and NAT gateways to allow instance deployed in private subnet to gain internet access. So for I can say for most common use cases, because I recommended that use NAT gateway instead of a NAT instances, because NAT gateway provides better availability and higher bandwidth and requires less administrative efforts than NAT instances. When I come to this one NAT gateway, okay, so he's giving me the subnets. Okay, which subnet I need? I have the public subnet, and I'm just asking me have an elastic IP because he himself give me one IP. Okay. Okay, so because sometimes elastic IP already allocated means you'll give this, you're not authorized to perform this operation. So I'm not worried about this one because the allocation IDs does not matching that one. So let me treat it again. So first of all, to create a NAT gateway, you should have a proper subnet and that IP that you should have, because NAT gateway is an Amazon managed resource that is designed to operate just like a NAT instance, but is simpler to manage and high available with an availability zone. And this instance, this NAT, because every instance that you have running EC2, that is they are running within private subnet to access internet resource through the internet gateway and NAT gateway. Okay, so that's why so this is important table that you have to understand here, but it takes some time for me to do that NAT gateway. Okay, before that we go here because this is a normal one, that NAT gateway you create. This is a managed service. Okay, so no need to break that much of head here. Come back to this. This is a VPN connection. Okay, just a minute. I will be starting lab again. Yeah, so coming back to my point here about this one customer gateway. Yeah, so actually this concept is something straightforward, because what is just if you have a knowledge of routing, okay, if you have knowledge of routing, because you can connect your existing data center to Amazon VPC and with using either hardware or software VPN connection, which will make Amazon VPC an extension of the data center. And the Amazon, I can say VPC offers different ways to connect corporate networks to VPG and CGW. So this is customer gateway. I need to have some dynamic routing protocol called BGP, or or maybe the dynamic routing protocol for like BGP and static routing and default routing. So if you have a routing knowledge, okay, you can understand this create a customer gateway. Actually, this is the concepts that between two sites, okay. So one site I am sitting now, and another siting. Another site is just my colleague is sitting in another site, or my office boss is sitting in another site. Means I need to communicate with those via this customer gateway. And this customer gateway between my site link and my boss link, there is a gateway that is established, a tunnel. I can say there is a tunnel between my site to my boss site. So this is something done by customer gateway, and you have to understand about the basic concepts of the routing protocols called BGP or something, because I need to follow these things, because because AWS VPC infrastructure is big. Yes, okay. So I got one question from one of the students. Okay. Okay, no problem. So okay, so let's continue. So that's why. So to create a customer gateway, actually, as I told, we must specify the type of routing, okay, that you plan to use when you create a VPN connection. If the CGW supports border gateway protocol, and then configure VPN connections for dynamic routing, like this. So there is a routing support should be connected here in order to create a customer gateway between me and my site and my boss site. Okay, so within this, that's why we have a lot of tunneling comes here, that internet protocol security tunnels, and also because Amazon VPC will provide the information needed by network administrator to configure the CGW and establish the VPN connection with the VPG, and the VPN connection consists of the internet protocol security tunnels for high availability to Amazon VPC. And that's why, so this is how this tunnel is. So because CGW, okay, customer gateway, is a hardware or software. This is a software on the customer side of VPN, and we must initiate a VPN tunnel between the, that's why it's asking the name and tag and IP address and BGP autonomous system number. ASN means is autonomous system number, like this here. So that's why, so this is a VPG, this is a virtual private gateway, that what we have. And this virtual private gateway, all those VPN connections works based on that. So we can have a VPN tunnel connection between my site to my another site. So this is how this VPC will gives you freedom of create your own tunnelings between two different sites. That gives you a lot of flexibility. That gives you a lot of freedom for you to have a private network connection between your site and between your another site. So this is how this VPC is all about. So we have discussed. So let me discuss about S3 storages next. So you most probably know one of the most wonderful and one of the most beautiful storage and extraordinary storage that we can say in AWS is something I can say is Amazon S3 storage. You know, Amazon S3 is one of the topmost storage we have in AWS, and other cloud vendors we have in the market like Google Cloud, and we have Windows Azure services. These all cloud vendors does not have this much of flexibility of storage as Amazon Web Services have, because Amazon Web Services, they offers one of the topmost storage services, topmost security services, and topmost networking services, and also development services across cloud is the AWS, and no cloud has matching capabilities to what is it to have a technologies like AWS have. So that's why if you start about S3 storages, so S3 storages, if you talk about S3, you know, actually people are got very highly struck with these types of storages called traditional storages. Okay, in traditional storages, you know, we have a lot of problems in traditional storage. What are the problems we have in traditional storage? I'm going to explain you that, and then I will stick with Amazon S3 storages here. So let me start the labs here. So when I'm talking about these S3 storages, this is something called object storage. You know what is object storage? Object storage means it does not have any file system attached with that. It does not have any any restrictions of the storages, and it is highly scalable and highly durable. And once you start work with Amazon S3 storages, I'm okay. So this for this the lab. Okay, so let me check it again. So yes, so that's why. So this S3 storage, because as I told in my already talk, there are two types of storages what we have in AWS. Okay, one storage is something called internal storage, and next storage is called external storage. You know what is internal storage? EBS storage that stick with Amazon EC2 Instance, and that internal storage is something that what we have seen, as I told, provisional OPS storage, magnetic storage, and general purpose SSD storage, as a throughput storage, and old HDD. These are all internal storage types, and there are some limitations like 1 terabyte to 16 terabyte, so from 500 GB to 16 terabytes, like this. But when it comes to S3 storages, I can say S3 storages is nothing but it is a object level of storage, and this is external storage in AWS. And this S3 storage is a short-term storage. Okay, it is not a long-term storage, because AWS designed S3 storage for short-term storage. And there is another storage also comes in mind that for long-term storage is called Amazon Glacier, and I'm going to talk about that also. So what is S3? Okay, let me talk about S3, because S3 provides developers and IT teams with secure, durable, highly scalable cloud storage. Because Amazon S3 easy to use object storage with simple web services interface that you can use to store retrieve any amount of data from anywhere in the web. That's why Amazon S3 also allows you to pay only for the storage you actually use, which eliminates the capacity planning and capacity constraints associated with the traditional storage. And you know, today one of the AWS, one of the topmost storage is one of those is Amazon S3, and Amazon is one of the first services introduced by AWS, Amazon S3, and it serves one of the foundational web services. You know, I can say nearly any application running in AWS they uses Amazon S3, either directly or indirectly, because Amazon S3 can be used along in conjunction with other AWS services. It offers very high level of integration with many other AWS cloud services. And for example, Amazon S3 serves as a durable target storage for Amazon Kinesis, Amazon Elastic MapReduce, and it is used as a storage for Elastic Block Storage also. Today, EBS is used. EBS storage is also serves as a Amazon S3 storage, and we have Amazon RDS, and also we have data stacking, loading storage mechanism for Amazon Redshift, Amazon DynamoDB, many other these functions, because Amazon S3 is so flexible, so highly and integrated and so common usage. That's why it's important to understand him as depth. So I can say the common use cases for Amazon S3 is backup and archiving for on-premises or cloud data, content, media, and software storage and distribution, big data analytics, static website hosting, cloud native mobile and internet application hosting, and disaster recovery. For this whole purpose, you can use Amazon S3 storages, and you can stick with Amazon S3 storage with Amazon EC2 instances. Okay, for example, how to attach S3 buckets, okay, with EC2 instances. Okay, for example, I'm going for EC2 instances. Let me launch one instance. Okay, so this is okay. So how if someone asks you how to stick with Amazon EC2 instance with Amazon S3 bucket? Yes, that is absolutely good question. So see, as I told, Amazon S3, Amazon EC2 instance, end of the initialization process completed of EC2 instance, you'll give one endpoint, okay, a DNS endpoint. I need to copy the DNS endpoint and then to attach with S3 bucket. Once I attach that S3 bucket with that specific endpoint, then my Amazon S3 buckets will stick with Amazon EC2 instance. You can see how to do that. You can just copy this one instance, okay. Just copy. Now go to Amazon S3 storage. Okay, so create a bucket. Okay, in order to create a bucket, you should stick with a particular S3 bucket with Amazon EC2 instance. Okay, so now I create a bucket. Okay, now just paste this. This is how you just copy, and this is the and since this Amazon EC2 instance has should come in specific region, and thus you can see I selected this region, and I can create a bucket. You can see now it's creating a bucket. So like this you can create a bucket. So once the bucket is created, it sticks with Amazon EC2 instance. And just remember that Amazon S3 is the one which is external storage for us. So external storage means we can able to store anything from our physical machine. Okay, this is my physical machine. So whatever data I have, I can attach, I can stick with those data with Amazon S3 buckets. Okay. Okay, let me launch S3 bucket here again. Just Yes, so I'm coming back with S3 storages because I'm just searching for that that lab. So that lab is extended quota. So I'll continue with this one. So that's why, so as I talk about S3 storages, they gives lot of flexibility for us to create a bucket, to copy the information from our local hard disk, that is my physical machine hard disk, to Amazon Web Services S3 bucket. So bucket is a flat folder, okay? It does not have any file system. When come to traditional storages like what I have in my operating system, you can able to see here. When I go to this properties of this one, they have a file system attached, right? Each and every storage have file system. Even if you go for elastic block storages, they have a file system, and they have a user space, free disk space. So these types of storages is something called traditional storage or block storages. That's why, so because traditional IT environments, two kinds of storages dominate everywhere. When you go to any private data center, block storage and file storage, because block storage operate low level and manage data as a set of numbers, fixed size blocks, and file storage operate at high level, the operating system level, that manage data, name hierarchy of files and folders. So both block and file level storage often access over the network in the form of SAN storage, or maybe block storage using protocol ISKC, fiber channel, or NAS storage, or something like we have different types of protocols, or CIFS or NFS. So whether directly attached or network attached or block file. So this kinds of storage is very closely associated with the server and operating system they're using the source, something like this. These types of storage, user fed up have used it. So now S3 storage came, and S3 storage is an object storage, is something different, because Amazon S3 is object storage. Because instead of being closely associated with the server, Amazon S3 storage is independent of a server and access over the internet. So that's why, so managing data as a blocks. So instead of managing data as a blocks or files using ISKC or CIFS or NFS protocol, data is managed as objects using API that is built on HTTP protocol, that is hypertext transfer protocol. So that's why these types of traditional block storages we don't have nowadays. After a few days, everyone will run behind object storage. That is called internal storage, and it has some limitation. But Amazon S3 does not have any limitation. You can have unlimited number of data inside this. You can upload unlimited number of data inside this. So I can upload. You can see here, I can upload any number of data inside this one. So I can, so any number of data means this does not have any folder or does not have any file system, because Amazon S3 object contains both data and metadata. Okay, so object resides in content. It's called a buckets. This is a bucket. This is, I can say, container. Each object is identified by user specific key or file name, because buckets are simple flat folder, okay, with no file system hierarchy. That is, you have multiple buckets, but you can't have sub bucket within a bucket, and each bucket can hold an unlimited number of objects. This is how the bucket is one of the most powerful storage nowadays people's running behind is, because I can say it's easy to think of S3 object, okay. You can easily think S3 object, oh, this is S3 object, oh, okay, it does not have any file system, it's just unlimited number of storage. Keep in mind that Amazon S3 is not a traditional file system and is different in significant ways, because in Amazon S3 we have something called get an object, put an object, because here everything we're referring as object, operating on the whole object at a once. So instead of incrementally updating portions of object as you would the file, you can't mount a bucket, okay. this bucket you cannot use for mount. You cannot open an object. You cannot install operating system on MS on S3, or you cannot run a database in it. Because instead of a file system, okay, MS on S3 is a highly durable and highly scalable object storage that optimized for reads and built in intentionally minimalistic feature set, and provides a simple, robust abstraction of files and file storage, and frees you from many underlying details that you normally have to do with to deal with your traditional storage today. And you know, Amazon S3, you don't have to worry about the device or file system storages, limitations and capacity, because single bucket can store unlimited number of files, and you also don't need, I can say, worry about the data durability or replication across multiple zones, because Amazon S3 objects are automatically replicated on multiple devices and multiple facilities within a region. So the same with scalability. So if your request rate grows steadily high and high, Amazon S3 automatically partition buckets to support very high rate request rates and simultaneously accessed by many clients. This is how this Amazon S3, and you have, so I think now you came to understand we have two types of storages. One is traditional block storages in AWS, and next one is a object level storages. That's why Amazon S3 is important for us, because Amazon S3 does not support any regions. You can see here the S3 does not support any region. This is your independent of regions. And also because even through the namespace for Amazon S3 bucket is global, and each Amazon S3 bucket is created in specific region that you choose. This lets you control where your data is stored, and you can create and use buckets that are located close to your particular set of end users, or minimize in order to have to reduce latency, or located in particular region to satisfy data locality. And also, if suppose also it gives you the total control location of your data in Amazon S3 buckets is stored in that region, unless explicitly copy it one region to next region. That's a different location. So here everything we're referring as a objects, everything refers as keys, everything refers as object URL. So that's why this Amazon S3, and you know the durability and availability. Data durability, availability, this is one of the topmost concept what we have Amazon S3, because durability, someone asks you, will my data still be there in future? But he is asking about the durability. And someone asks you, can I access my data right now? He is asking about availability. Yes, because Amazon is designed to provide both very high level durability and high level availability of your data. So Amazon stands, because Amazon standard storage designed for 99.9999% durability and 99.99% availability of objects over a given year. You know, that's why. So that's why Amazon S3 achieves high availability by automatically storing data redundantly on multiple devices in multiple facilities within a region. It is designed to sustain the concurrent loss of data in two facilities without loss of user data. So Amazon S3 provides highly durable storage infrastructure designed for mission critical and primary data storages. If someone asks you, okay, if I store non-critical data, okay, non-critical data means I can say images and thumbnails, so that type of data does not require this high level of durability. I accept that. That's why Amazon has introduced one more storage called reduced redundancy storage for RRS. I will show the storage here. When I go to change storage class, okay, see there are three types of storage. This is I'm talking about reduced redundancy storage, and this is also offers 99.9% durability with lower cost of storage than traditional Amazon S3 storages. So Amazon S3 have three types of data storages, right? Standard and standard infrequent access, and they reduce redundancy. And standard means he will be giving the time of 30 days of accessibility. When you have lost 30 days of accessibility, then it will become infrequently accessed and sent to Amazon Glacier for after 30 days. So after 30 days you are not accessing, go to 90 days. After 90 days you are not accessing, it will be keep in long-term storage as a 3-year storage for in Amazon Glacier. Okay, so that's why this Amazon S3 objects, Amazon S3 storages are one of the most popular storages, because there are three types of storages that you are seeing here: standard, infrequently accessed, reduced redundancy. When come to standard, because this offers high durability, high availability, low latency, and high performance object storage for general purpose use cases, because it delivers low first byte latency through the through the and standard is well suited for short long-term storage of frequently accessed data, and this is one of the most general purpose use cases storages. When it comes to infrequent access, many people are getting confused because this also offers durability, low latency, and high throughput as Amazon S3 or standard, but it's designed for long-lived and less frequently accessed data. And standard infrequently has a lower GB month storage cost than standard, but the pricing model, this is very less and includes a minimized object size of 128 KB and minimum duration 30 days per GB retrieval cost. So it is best suited for infrequently accessed data that is stored for longer than 30 days. This is, as I told, one more story. This is RRS, reduced redundancy storage. It offers slight lower durability, but than standard and standard infrequent access, reduced cost. It is the most appropriate for derived data that is easily reproduced, such as image and thumbnail. There is one more storage I think I have not discussed with you called Amazon Glacier, because Amazon Glacier was a world-class long-term storage and secure, durable, extremely low-cost cloud storage for data that does not require real-time access, such as archives and long-term backups. To keep our cost low, AWS Amazon Glacier is optimized for infrequently accessed data when the retrieval time of several hours is suitable. To retrieve Amazon Glacier object, you should once you store data in Amazon Glacier, after 3 or 5 hours later, the Amazon Glacier object is copied to Amazon SS3. So suppose that's why. So restoration simply creates one copy to this. And just remember, Amazon Glacier allows you to retrieve up to 5% of data of Amazon S3, and that is a free of cost for each month. So you restore it beyond that, the AWS will provide you more per hour cost for that. So that's why Amazon Glacier is a standalone storage services with separate API that have unique characteristics of Amazon S3. So many people are asking questions like, what's the difference between Amazon Glacier and Amazon S3? Yes, that's the basic question, because Amazon Glacier and Amazon S3, they have similar characteristics. So those things, once we start discussing, okay, it will take a lot of time for us because I can keep on discussing with you lot of stuffs, lot of practicals, lot of technical stuffs inside AWS cloud services, because AWS cloud services is not the concepts that we discuss within 2 hours or maybe within 1 hour, because it has to be discussed in depth. It has to be discussed in structured format. It has to be discussed in such a way that you should get crack in examination purpose as well as for interview purpose as well as for self-development. So today I have given a talk on AWS. So I think you understand the overall session that starting from starting to end to now. So that's why. So those people are not joined today. They will be getting the recorded version of this session across the YouTube, or maybe you'll be getting across your mail. So I'm from Zeedup Technologies, so you can ask me any questions that you have right now coming in your mind, because I want to know, because your internal views, but because I don't know how strong you are in technical stuff, but I'm here to make you more strong in technical stuff in AWS, because you can I can give talk on AWS, not even AWS. I can give talks on Windows, Azure Cloud Services. I can give talks on Google Cloud or other cloud vendors that what we have in market, but one of the topmost vendor what we have in cloud services is AWS, and AWS is one of the rapid cloud services. They are providing the cutting edge technologies across and they have the rapid provisioning concepts, and also we have the on-demand IT delivery services. So that's why today we are here to understand the AWS. So we need to understand more depth of AWS components. We need to understand more depth of AWS services, and also their high availability, and also they are secure, and they are one of the most the high level archives of the components they are providing. So anyway, thank you so much for your time today, and I hope you understand today the overall the sessions, what we have done, what we discussed with you. So thank you so much, guys. If you have any doubts, or you can please contact this number. I'm just posting in my chat message. So you can please contact that number for any queries and for any whatever. So if you have any important doubts you have, or maybe you're not trying to expose yourself right now, you can contact that number that I sent you in chat message, and you can clarify that. Anyway, thank you so much for coming, and as you requested me that you will be getting this recorded version of this class immediately. Thank you guys. Thank you for your time. See you back. Take care. Bye-bye.